Welcome to the Indiana University Flume Lab in Bloomington, Indiana. Today we are going to show you a small movie about bedload transport of mud by floccular ripples, and especially those aspects of transport that you normally cannot see because the flow is too murky. We are conducting a wide range of experiments in mud deposition and erosion, and we always start with finely ground clays. In the experiments we show here, we used kaolinite, but other clays work basically the same. The kaolinite forms silt to sand-sized floccules. And the larger floccules travel in bedload. At velocities between 35 and 50 centimeters per second, they mostly travel in form of boundary layer streaks.
But once flow velocity has been reduced below the critical velocity of sedimentation, flocculures form migrating ripples.
The critical velocity depends on the suspended sediment concentration, but generally falls within the 20 to 35 centimeters per second range.
As ripples migrate, they are not fully eroded, leave behind a tail, and gradually a mud bed accretes.
Because of the murky nature of the flow, we are lucky to see the shadows of ripples with backlighting. We can't see the ripple surfaces. If you want to see the ripples from above, we have to drain the water. And at that point, the whole process is already over.
We call this the uncertainty principle of mudstone sedimentology.
When they move, you can't see them. And when you can see them, they won't move.
We do, however, have a few tricks up our sleeves.
For example, when a ripple runs into the wall of the flume, we see its cross-section. We can see that floccules accumulate at the ripple crest, and once enough of them have piled up, they start avalanching down the foreset slope. They do so in the shape of tongue-like sediment bodies that are comparable to terrestrial mudflows on hillsides. Through this process, we get overlapping flows that build up ripple foresets and propagate the ripple in downstream direction.
Another trick is to replace the milky flume water with clear water.
This has to be done carefully because the sediments are very watery and easily destroyed. While usually we feel through the bottom of the flume and see floccular streamers and migrating ripples, When water replacement is successful, we can see the ripples from above.
Once we restart the flow after water replacement, we can observe what's going on over the top of the ripples.
We can see flocule streamers weave back and forth. We can see sediment trapping in the lee side vortex, ejection of sediment clouds. And foresight buildup by downslope motion of sediment lobes.
So, just to compare again,
when viewing from below, we can guess the sediment avalanches downward. But when viewing from above, we can see that it actually is happening. We see much more detail of the lobes and the overall geometry.
These experiments confirm what we said before about ripple advance and ripple migration. But now, because we can look at things directly, it is quite a bit more convincing.
What our experiments show us is that floccule ripples of mud are not much different from sand ripples, except for their water content. They migrate the same way and show the same morphological features, but migrate slower because of cohesive forces. Internally, the accumulating clay beds show claniform layering, just as we should expect from deposit that reflects ripple migration. The clay bed consists of inclined layers that themselves are composed of overriding ripples. This is revealed by horizontal cuts that show sets of curved ridges, the rib and furrow structure so familiar to us from ripple sandstones.
Of course, once these muds are compacted, their cross-lamina will look quite parallel and horizontal, pretty much like many of the finely laminated shales of the rock record.
But even this, when looked at carefully, may show evidence of compacted muddy ripples. So, does that mean that all laminated shells were deposited by current ripples?
Probably not.
But in the future, we have to keep this in mind. And as we learn more, mudstone sedimentology will become not only more complex, but also more informative.
The Indiana Flume Lab. Mud happens.